My name is Granville Matheson, and I'm going to be presenting an introduction to mine and Martin's presentations about BIDS apps for pet data. So, BIDS apps are tools which make use of the Brain Imaging Data Standard, or BIDS. And just to very briefly describe BIDS, BIDS is a standardized structure for naming and organizing neuroimaging data. So it basically specifies a set of rules and file formats by which to store neuroimaging data. And its goals then are to make it easier to share your data within or between groups, to make it easier for other researchers to use your data because it follows the same standardized structure, for analysis tools, and these are called BIDS apps, to automatically ingest and process your data, because the idea is that BIDS is both human readable but also machine readable. So if the data follows the specification, then some tool called a BIDS app should be able to automatically read the data and all of the relevant information about that data in order to be able to process it. And finally, by using these BIDS apps, using standardized apps with standardized data, it becomes much easier to record and to document what was done with a given data set. So BIDS is not limited to PET. It has a long history with many different methods. It started off being applied to MRI. Then there was the BIDS apps. There was a paper describing BIDS apps and how they work. And this was followed by MEG BIDS, by EEG BIDS, by intracranial EEG BIDS, and a number of other methods, and there have been a number of other modalities, and there have been other modalities since then too. But in 2022, PET was added to the final BIDS, to the BIDS specification officially, and there became a PET BIDS specification. So just to very briefly describe what's in the PET BIDS specification, it basically states that PET images should be stored as NIfTY files. Values and information should be stored in JSON files, which are effectively a special kind of text file. And tabular data should be stored in TSV files, which one can open with Excel, but they're effectively also text files where each column is delimited with tabs. So in the PET BIDS paper, it's described what is contained in here, and you can also read more about it on the BIDS specification website. But basically in the dataset description, it says what is in this dataset, in this study folder. We have the NIfTY, the PET NIfTY file basically contains our PET image, our PET images from each of the frames. We have our PET JSON file, which contains the key value pair, that contains the information about that, so the manufacturer of the system, as well as the radionuclide, the injected radioactivity, and so we can get all of that information in these JSON files. We also have blood files, so here we have the tabular blood data in a TSV file, where we have our time, plasma radioactivity, whole blood radioactivity, etc. We also have in the JSON file accompanying that, so with the same file name except with JSON at the end, we have some information about the blood file. So we have, is plasma available, is whole blood available. We also have what is time, what are the units of these time values, etc. Then we have in the PET folder, we have all the PET information. We also have an anatomical folder where we have here the T1 weighted NIfTY file, so that'll be the image file from the MR, as well as the JSON describing what the relevant properties are about that image file. So I've talked now about the raw PET data, which is over here. We have our subject 1 anatomical session baseline and session blocked PET. So we have our PET images and our anatomical images. But there's also this folder over here called derivatives. So these subject folders contain the raw data, but in the derivatives, this is where BIDS apps can produce their output. So BIDS apps output can either be an independent dataset all of its own, where it's a derivative dataset, but we can also include it alongside the raw dataset in this derivatives folder. So, as I've mentioned, BIDS apps can ingest and process BIDS data and produce this derivative data. So, I've mentioned they produce derivative data, but there is now a drive within BIDS that has come some way to actually standardize this derivative data too. So by standardizing these according to an extension of the BIDS specification for raw data, but specifying how it should be for derivative data too, these BIDS apps can actually not only be used to access the raw data, but also to work together alongside one another. So they can automatically ingest the outputs of one app as an input to the next app. So the PET pre-processing derivatives specification for BIDS is currently a work in progress. If you would like to contribute, you can go to the BIDS website, go to extensions and find the BIDS extension proposal 23. And you can work, this is led by Martin Nørgaard, and you can make your suggestions to the specification before it is incorporated into the official BIDS specification. But what this allows us to do, as I've mentioned, is to use these apps side by side. So Martin is going to talk about SMRI prep, as well as PET prep, which uses the outputs of SMRI prep. So here we have the raw data at the bottom. Then SMRI prep will work with the MR image data to produce structural MRI preparation. Then PET prep will use the outputs of SMRI prep as well as the raw PET image data. And then I'm going to talk about Bloodstream, which works with the raw PET blood data, as well as PET fit, which uses the outputs of Bloodstream as well as the outputs of PET prep together in order to perform kinetic modeling and quantification of PET data.